Hello, everyone. How is everybody? Can someone confirm that you can hear me and you can see my screen? Thank you, Matthew. Thank you, Howard. Thank you, Matthew, again. All right, it is 6:30. I want to respect your time. Let's start. Any questions before we start? Anything? Last class, we did chapter 9 in our first textbook, ARIMA methodology. We did 7 examples. Today, I will finishing up last class. I will do a couple of remaining examples. Oops, why this does not register? That's too bad. What happened to my pen? I don't know. Okay, let's go. So after finishing chapter 9 in our first textbook, we will do our second textbook. Remember, our second textbook is free, available at this website. See, where's my mouse? Free, available at this website. We'll do 2 chapters. Today we'll do chapter 9. Next class we'll do chapter 11 for those second textbook. Just a reminder that the project is extended from until Saturday, April the 9th by midnight. Project due April 9th. Okay. If you are doing project in a group, you also need to submit peer evaluation. Okay, under the D2L assignment, then go to peer evaluation. If you do the project by yourself, you just submit your project. And when you do the project in a group, each and every student will submit the project, not just group submission, individual submission for your group project. Okay. All right, any questions? All right, so I will go back to last class to finish up the remaining examples. That is our week 9. Here. Okay. So I will start off with last class. We did 7 examples. Example 1 to example 7. So today I will finish up example. I will do example. This is not 9.9. Example 9.8. Okay, example 9.8. In this example, I will explain the criteria for model selections. Usually, we use either AIC, stand for Archaican, the information criteria of Archaican, okay, AIC criteria, or we use Basic Information Criteria, BIC. Those criteria are based on 3 factors. The first factor is sigma square. It is the residual sum of square divided by number of observations. Sum of square of residue divided by number of observations. So this is sigma square. And then take natural logarithm, ln natural logarithm. N represent number of observations. R is the total number of parameters, including the constant term. Okay, so based on these three items, we can calculate AIC. And we hope the smaller the AIC, the better the model. So if you are creating two models based on the same data set, pick the one have a smaller AIC, other conditions equal. Okay, and for the BIC, Bay information criteria, similar formula, but instead of 2, this part is different. This is 2, and here we have a log n. That is the only difference. Other items are the same. Okay, so those are the two criteria. Any questions? So final exam, if I give you sum of square for residue, just for example, okay, 980, and I gave you observation n equal to 50, number of parameters equal to, let's say, 3, just for example, I give you those 3 items. I ask you, what is AIC? Okay, so you plug in this AIC formula. So before you plug in formula, let's figure out what is sigma square, sigma hard square. See, sigma hard square is the sum of residue squares, residue sum of squares I gave you, divided by number of observations. So that is the sigma square, okay? And to facilitate calculation, I am going to use an Excel. Okay. So equal to 980 divide 50. So 19.6, okay? And this number, I'll have to take the log. So equal ln log this number. Okay, so that is a ln sigma square. So AIC equal to log 980 over 50 plus 2 over 50 times 3. This over times 3. So the result would be the first item I already calculated. So what is the result of 2 over 50 times 3? And then add these two numbers together. So AIC is 3.09. Okay. Similarly, you can calculate BIC. Okay. I give you different number based to illustrate the calculation for AIC. The textbook give you another numbers. It is based on 9.4. You can try it out. So that is the example 9.8. Next, I will do example 9.9, forecasting sales. If you have the data with seasonality. Last class, when we did example 1 to example 7, we haven't seen an example involving seasonality. So this example will touch upon seasonality. How about if the data experience the seasonal pattern? Okay, so the data file I'm going to open, it is example 9.9. So I will directly go to SPSS. Actually, this is the data file I already opened. Example 9.9. I will try to delete the original data so that I can start all over again. So delete all of those. One by one. So this is the sales data, okay? And this data is based on January 1997. The first data represents January 1997. It is monthly data. The last data represents July 2006. Okay, July 2006. So first step, as usual, we are going to create sequence chart to see the pattern of this data. Okay, so we go analyze, forecasting, and then sequence chart. We put the sales data into the variable, and then click OK button. This is not the data. Okay, I will redo it. Analyze, forecasting, sequence chart. Yes, it is here. And then click OK button. Okay, it is here. See, this data obviously have seasonal pattern, and also it is upwards pattern. Okay, it is not stationary data. It has seasonal components. It has the trend component. Okay, so we get this chart. Next, let's explore the autocorrelation functions for this data. So go back to the data, go to analyze, forecasting, autocorrelations. So variable is the constraint cells, and then click OK button. So this is the ACF function. Obviously, the data are it is a time series data. The residues are related to each other. There is a spike in the first time lag, as well as this one here, actually 1, 2, 3. The third one is also has a spike, okay? And if you check the partial ACF, same thing happened. There are several spikes. That means the data are highly correlated, okay? And now, because of this reason, we want to do the difference. We want to do the difference to see if we can get a good module for autocorrelation. Okay. Any questions? Do I see any questions? Okay. No questions so far. So now let's do the difference. So go back to this data. Analyze, forecasting, autocorrelations. So this time we we do the difference and then do the autocorrelations and partial autocorrelations. Okay. So click OK button. And this time, we check the ACF still have the spike, especially at time lag 12, a big spike here. And the partial ACF, again, at time lag 11, big spike here. Okay. So after examine those, what we propose, we are going to propose a model, a ARIMA model with seasonality. Okay. So the model we are going to propose. So we did those explorations. Okay. This short after we do the transformation, it is a little bit more stable. Okay. It is changed around this constant. Okay. After we did the difference, but still have the big spike. Okay. So next, we are going to build a model. This model is ARIMA. Okay. So 0, 0, 0, it is just actually the white noise. And then seasonality part, we are going to use one difference for seasonality and one difference for the residue. And it is monthly data, so the seasonality is 12. We are going to create this module. Okay, create this module based on after create the module, and we are going to forecast. Remember the last data. The last data is July 2006. We want to forecast August 2006, September 2006. You specify a parameter through this one here. Okay. All right, so let's do this part. So you do analyze, forecasting, create traditional model. It is asked you to define date and time in order to use seasonality. Otherwise, the computer does not know. It is quarter, the seasonality is based on quarter data or monthly data or weekly data. We need to tell computer this is monthly data. So you quick define date and time. And our data is monthly data. So we select year, month. The first data represent 1997, January. So you type in 1997. January means 1. Okay, so January 1997. That is our first data. And then you click OK button. And now go back to your data. So the computer automatically specifies the year, month, okay, automatically create those 3 columns for you. Okay.
Professor,
so after,
sorry, I just have a quick question. I'm trying to do the same thing, but when I go to analyze forecasting and then create traditional models, that option to make it seasonal doesn't pop up for me.
Okay, if that's the case, you do this. The question was you cannot create these 3 columns. Is that your question?
Yeah, it's just not, it doesn't give me the option.
Okay, you do this. Let me see. Who is speaking?
Matthew.
Matthew, yes, Matthew, you do this, try to do this. Okay, I will try to do this with you. So I'm going to delete what I did. So did you get this data, right, Matthew?
Yeah.
Okay, if you are not given that option, you do data, quick data button.
Yeah.
You go to define date and time.
Mm-hmm.
Define date and time. And now you select yes, months.
Okay.
And in year, you type in 1997.
Yeah.
And months, you type in number 1.
Okay.
Then you click OK button.
Okay. Yeah.
And then you go back to the data. See, you have additional 3 columns.
Oh, perfect. Thank you so much.
You're welcome. You did it, Matthew. Thank you for your question.
Yes.
Okay. Any other questions? Okay, please feel free to ask questions. Okay. So where we are? Okay, we are here. We created the defined the date and the time, specified the first date is January 1997. Then we go analyze, forecasting, create traditional model. Okay, dependent variable, constraint cells. From the method, select ARIMA. And then quick criteria, you have this one. So this is the seasonal data. We want to do the model. This part is 000 for seasonality. We want to do the difference is 1. Okay, moving average Q, we want to do 1. Okay, so this is because we define the data is monthly data, so the seasonality it is 12. If the data is quarterly data, this number should be 4. If the data is weekly data, this number should be 52. Okay, so we click continue, and then on the statistics, because I already introduced BIC, Bay Information Criteria, so we want to get this statistic, Bay Information Criteria, and we want parameters estimate. Okay, and we want to display forecast. And on the plot, I'll pause for a moment to see if you have any questions. On the plots, usually we need this one, residue autocorrelation function, residue partial autocorrelation function. Okay. Anything else we need some, we check out the BIC again. This is the plot, so maybe I just ignore that. I want forecast value. Yeah, that's it. Usually we don't do anything about output filter. So go to the save. We want to save predicted value. Usually we'll do this. And the options, we want to forecast. Remember the last date in original data represent July 2006. So depending on how long you want to do forecast, you can type in year. We want to forecast for 2006 months, maybe months. You can type in September. You can use the short form, okay, SEP, represent September. September. And that's it. Click OK button. And this is our module name, module type. Okay. Those are the module fit, the R-square value, mean, RMSE, etc. And this is our model statistics. We hope the L-gene box is not significant. So this is good. Okay, we need this SIG, the p-value is greater than 0.05. Okay. And then we get ARIMA model parameters. Okay. We got, because we are using seasonal MA, so this number, this parameter is 0.669. Okay, 0.669. So I want to do some annotation. I will go back to my output here. Okay, so this constant 86, I try to make this bigger. This constant is actually our mu, okay? So the model is, this is our mu, and this one is, because this is the first time we are using seasonality through ARIMA model. This is a capital omega. Omega represents the moving average part, MA part, okay? And we just have one omega, okay? So the model should be this one here. Remember, we did a difference for seasonality. Remember, our model is ARIMA 000. This part is the regular part. Then we focus on seasonality part. The second, this one is a seasonality part. This is monthly data. We usually put 12 as a subscript. This one represents difference. Okay, a difference for what? For seasonal means, because this is a 12 months. Okay, so we use YT minus 12. That is the difference. We don't use this month minus last month. We use this month minus last year of the same month. So this is YT minus 12. So T minus 12 represent the same month, but from last year. Okay. And then this is the moving average part. We use this big omega. We use this big omega. So this is in the textbook formula 9.9. If you have monthly seasonal data and you have just one order of moving average, this is the formula. This is actually the model. Okay, moving average model for monthly data. Okay. And this epsilon t usually is 0. When you do forecast, set epsilon t is 0. So this model actually becomes, without this item, delete this item, you just need mu. Mu is from here. Mu equal to 86.211, and you need omega. Omega is here, minus omega, so minus 0.668. Okay, and this epsilon t minus 12 is the residue for 12 months before. Residue for 12 months before. Okay, so how do you calculate the residue from 12 months before? Remember we saved our forecast. See, this value is our forecast. So if you want to forecast, so this last number, this number represents July 2006. If you want to forecast June, July. If you want to forecast August 2006, you go back to 12 months. Okay, you go back to 12 months. I want to forecast here, okay? So you get this number here. Did you see where is my mouse here? You go back to 12 months. And then you look at original data, 2275 minus predicted data, 2353. You do subtraction. That result is the epsilon in the formula. Is this guy here, epsilon t minus 12. Okay. And you know the omega 1, you know the mu. And you also know y t minus 12, okay? So if this is your y, you are going to forecast going back 12 months, y t minus 12 is 2275. And then you can forecast next yt. You can forecast yt. Okay. Any questions on the theoretical part? How do you forecast yt? Now let's go back to original data here. So original data, if you every month, if you give 1, 2, 3, see 1, 2, 3. So the last one is 115. So you want to forecast the sales for 116. Okay, so let's forecast Y116. Okay, so let's do this. Y116 forecast. Okay, so Y116 minus. Let's write down this formula first. I want to forecast 116. Then I need to use Y116 minus 12 equal to mu. Mu is 86.211. And then minus big omega 0.668 times omega t minus 1. Okay, so you need to do the forecast for what is omega t minus 12 when t equal to 116 minus 12, so equal to what? 104. So you go to row 104, go back here. 104 here. This row, this is 104. Original data is 2275 minus 2353. You can do subtraction, but if you want computer automatically calculate this difference, you do this. Transform, compute variable. So our reset. So this variable is actually epsilon. So I will use maybe just error term, okay? The error. What is the error? It is original data. This is original data minus predicted data. The difference between original data and the predicted data is the error, epsilon. Okay, click OK button. And then you go, see, this is the error term we get. Okay, so we need 104, row 104. So the result is a negative 78.15. We get this number. So, okay, so 2275 minus 2353.15 equal to negative 78.15. Okay, so this number equal to negative 78.15. Okay, so go to here, 0.660 times negative 78.15. Okay, and then you do a little bit algebra, you will get, this is the equation, by the way, okay? Our objective is to find why this is hard, means predicted, equal to 116 minus 12, that is actually y what? 104, okay? Then plus 86.211 minus 0.668 times negative 78.15. Okay, just move this chart. So what is y 104? This is y 104, 2275. 2275 is y 104, 2275. Okay, so you go to plus 86.211 minus 0.668 times negative 78.15. Okay, and the forecast for this value is 2413.4. Okay, so this is our calculation by hand based on this model, here. Now, what is the computer forecast? See, the computer forecast when you match our hand calculation. This is the computer forecast for August, see, August 2006. Okay. Any questions for using ARIMA model with seasonality? Any questions? All right. So next, I will go our last example in chapter 9. It is a 9.10. Okay. This time, we are going to propose two models. Although I haven't given you the data, I will just give you the idea. The data, usually it is the sales data, okay? This is the data. So I'm going to propose two models. One is ARIMA, 110, and then seasonality is 0, 1, 0. This data is quarterly data. The other model is ARIMA. And then from these two models, I'm going to pick a better model based on maybe BIC, okay, big information criteria. So the other model is this one. Okay. So let's take a look at the data. So this data is the sales data, okay? When you do the autocorrelation function, you see the spike, like time like 1, like 4, okay? Like 1, like 4, like 8. So it is a quarterly data. Okay. And then when you're dealing with seasonal data, you have to define the date and the time. So this data is starting 1994. There's a typo in my PowerPoint slide. Sorry, it is 1994 first quarter. Okay. If you are not given this option, you go to the data, define date and time. Okay. You are going to get this data. Okay. So now I'm going to, after that, you can explore the data. Okay, so this is some ideas. Now let's actually do it. So this is my 9.10 data. I already did something, but I want to delete all of the stuff I have done so that I can start from scratch. So total we have 52. Okay, observation 52. The first data is 1994 quarter 1. So let's define data. Let's do this way. Data, define date and time. We use years, select years quarters. And the year is 1994. Quarter is from the first quarter. The first data represent the first quarter in 1994. Okay, and then click OK button. So now go back to the data. See, you have this additional 3 columns. Okay. After that, you create a sequence chart to explore the data pattern. Okay. So go to Analyze, Forecasting, Sequence, Charts, quick cells, Data, then click OK button. So this is how the data looks like. Obviously, it has the seasonal pattern. Okay. It is not stationary data, and we might to do the difference. Okay, that's why when I propose the model, I have difference in the regular ARIMA model as well as in seasonal ARIMA model. Okay, so this is the sequence chart. I already showed you the autocorrelation, so I will skip that part. Now I will directly jump the 2 models I proposed. Okay, one model is here, ARIMA. Let me use my mouse. 110 and then 010. So the first bracket, this one means the data related to one data before. And this one, second one represent you difference the data, original data, do the difference. This is the regular ARIMA. The second bracket represent seasonal factor, seasonal, and we do the difference for seasonal. This is this number 1 represent. Okay. So let's dive into the, and those are the screenshot. So let's do the live demo for 9.10. So go to Analyze, Forecasting, Create Traditional Models. Go to Variables, Cells. Yes, you can reset everything just on safe side. Dependent variable is cells, and then ARIMA criteria. So we need 110. So type in 1, and then 1, 0. This is a regular ARIMA, also called non-seasonal. And for seasonal, we want to do seasonal difference. So 0, then 1, and 0. Okay, it automatically gives me the 4 because it knows this is the quarterly data. Now click continue. And then under the statistic, we want BIC, Bayes information criteria. We want the parameter estimate. We want to make forecast. And then plots, we usually need these 2. Okay. And then save forecast. Under the options, what do we want to forecast? We want to forecast in order to specify this, you have to know where is our last data. Our last data is row 52. It is Q4 in 2006. Q4 in 2006. Okay. So if you want to forecast, depending on how many forecasts you want to do, if you want to forecast 2 periods ahead, so it should be Q1 in 2007 and Q2 in 2007. So here you type in 2007 and then Q2. This is the case after the end of estimating period through a specific date. Okay, so we want to forecast 2 quarters. Then you click OK button, and you get this output. I'm going to go back to my OneNote to make annotation based on this. So this is our output. So we have, so first of all, look at this p-value is good, greater than alpha 0.05. So it is a assurance. And then you want to write the model. Those are the parameters. Those are the parameters. So specifically, remember our model is our model is 1, 1, 0, then 0, 1, 0. This is for quarterly data. Okay. And then we need to do actually, let me see. This is a there are let me see how to write down this model, because there are regular one and so first, if you look at the constant, the constant is this is p-value 0.5 greater than alpha. So we actually eliminate constant. We don't want the constant in the model because the p-value is big, the constant, okay? So we want to eliminate, ignore this value here, ignore this value. And then just based on AR1, just based on this AR1 here, we can write down the model. Remember what is AR? AR means if I use W represent Y, I will explain why I use W, okay? Equal to negative 0.337 times WT minus 1. If you want to use the data T, it is connected to 1 period ahead, T minus 1 period ahead, and there is a parameter here. The parameter is negative 0.337. Okay, so this is this one. And then what is my WT? What is WT? And to explain WT, we have to know this data is different at seasonal. Okay, so for example, Q1 of this year minus the last quarter. Okay, so if I have YT is the current number, so one quarter before it should be T minus 4. Do you agree? 1 quarter before T is T minus 4. Do the difference. This is this meaning. This number 1 represent. Okay, represent YT minus T minus 4. Okay, and next, let's explain this number one. This number one. This number one is just the regular difference. Okay, so you are going to do the difference for this number. I use this triangle. In mathematics, this is actually data. Data represent the change. Okay, so I'm going to do this one. Okay, so if you consider this as a whole, what does this? So normally, when you see a 1 in this position, you would say yt minus 1, t minus 1. You would do this normally. But since this is my whole object, so if you want to do this change, you have to do this. It is so you keep the first item, yt minus 1, t minus 4. Okay, and then minus. What is the number before it? Change t to t minus 1. Whenever you say t, change to t minus 1. So this part is a little bit complicated. I pause for a moment to see if you have any question. So we do difference 2 times. One is at this red, at seasonal. Okay, so current value minus a quarter before. The other is do this difference. Okay, yt minus 1. Okay, and now you do a little bit algebra. So this number becomes what? Sometimes I don't differentiate the capital and the smaller. You do take away this second bracket plus yt minus 5. Okay. So what is this? This is my wt. This is my wt. Not this one is let me see. No. Try to. Okay. So now yes, this is my wt. So remember I asked what is my wt. This is my wt and this is my wt. Okay, and then simplify my wt. I will write down this is yt minus 1, and then minus yt minus 4 plus yt minus 5. This is my wt. Okay, and then you plug in wt here. And here you see wt minus 1. So whenever you see t, you plug in t minus 1. So wt minus 1 should be equal to yt minus 1, yt minus 2, yt minus 5 plus yt minus 6. That is your wt minus 1. Okay, and you plug in this into here. All right. So after that, and how do you do the forecast? That is our question after all of these algebra calculations. Okay, so the forecast, I will use my regular color. Maybe I will use blank. I use blank. So yt, YT actually equal to, it is a long formula. I have to find a space. Try to, okay. So YT, I want to forecast YT equal to YT minus 1 plus YT minus 4 minus YT minus 5 minus 0.337 times bracket. Inside the bracket, you have YT minus 2, YT minus, this is YT minus 1, YT minus 2. Not a 2, 6. Inside T minus 1. So T minus 1, T minus 2, then minus T minus 5. Plus T minus 6. I'll need to double check. I need to double check something here to make sure it is correct. So YT minus YT. This is correct, WT. Yeah, I'm pretty sure this is correct. So this is the one you are going to use to forecast for YT. Everything on the right-hand side, you can find out. For example, if you want to forecast Y hat, remember the last data is 52. If you want to forecast 53, so equal to Y 52 plus Y, this is T minus 4. So 53 minus 4, 49 minus Y, T equal to 53 minus 5, 48 minus 0.338, then Y 52 minus Y, T equal to 53, 53 minus 2, 51, minus Y, 53 minus 5, 48, plus Y, 53 minus 6, 47. This is the forecast value for 53. You can get Y52, Y49 from original data here. This is not this example, this is. See, this is Y52, Y51, Y50. See, where's my mouse? Y49, Y48. Okay. Any questions? Okay, so this is a forecast by hand. Actually, the computer gave us the forecast. It is here, 178.85. That is Y hat. This number is Y hat 53. Okay. Any questions? Okay. So this is one model. And through this model, remember we need to check for BIC. So where is my BIC? Bay information. See, this BIC 7.135. I'm going to copy this into my OneNote because I'm not so sure if I have that one. Please. Okay, so I have BIC value here. Where is BIC? normalized BIC. We want to copy the normalized BIC 7.135. So it is this number here, BIC. Okay, so that is the first model we proposed. Okay, similarly, you can propose a second model. The second model we are going to propose is, I don't have, so the second model we are going to propose ARIMA 110 and then 0124. It is exactly the same procedure. You just go through it. So I'm going to quickly go through it. The objective, I want to find BIC to compare with the first model. Okay, so go to analyze. I'm going to this time go fast because it is exactly the same procedure. So I'm going to criteria, it is 110 and then 012. Just change this to 2. That's it. Just change this to 2. And everything else remain unchanged. Okay, and I click OK. I try to find the BIC. This time it is 7.048. I will paste it here. Do I have option to paste as picture? Paste as picture. Okay. So this time I can clearly identify. So where is my BIC? 7.048. So this obviously smaller than this 7.135. So that means this model is better than the first model we proposed. All right. Any questions? So the summary of chapter 9 in our first textbook, all the important formulas are here. Okay, all the important formulas are here. Any questions? All right, that concludes our first textbook. Let's take a break. After break, we will use our second textbook. And in second textbook, we'll go over 2 chapters using RStudio. Hope you installed. If you haven't, don't worry too much. The requirement for the last 2 lectures are you understand the concept. During the final exam, I will not ask you to using R, but I will ask you to explain the output from R. Okay, okay, let's take a 10 minutes break. By the way, the number of COVID has increased. This a little bit worried because I teach another class. Several students reported COVID cases. So take care of yourself, okay? Let's take a 10 minutes break, come back at 744, okay? Break, 744, okay, back. I'm going to stop recording. When we come back, I will start recording again. Stop recording.